Okay, so we got cut off there in that last video, but there's not a whole lot left, so we'll just pick up there. So to recap what we just talked about, um, the if I were you, I would absolutely print this slide here. The PowerPoint's going to be posted. I would print this slide and keep it handy because I realize this is a lot. So the sample standard deviation is this formula with n minus 1 in the bottom. The population is with n in the bottom. Sample standard deviation is called adjusted. Population standard deviation is called the unadjusted because it doesn't have that n minus 1 in the bottom. The hand calculations that you're going to be doing for the textbook and for MyStatLab, that's the second calculation here. That's the one with n in the bottom. The variance is s squared or sigma squared, and that's just the values that are underneath the square root here. Or if they give you the standard deviation, you could just take it and square it. And then the top part of this fraction here underneath the square root, that's called the sum of squares. All right, so now one more thing to talk about in this lesson, and that is box plots. Box plots are a really good way of looking at distributions, especially having to do with outliers. So this is an example of a box plot, and this is a data set of waiting times at a bank. So we'll go through and talk about what all the values mean. So the box, this part here is called the box. And the lines here, this line is the 25th percentile. That's the data value with 25% of the data is below it. And then this is the 75th percentile. So this is the data value where 75% is below it. So that tells you that the middle 50% of the data is between this value here, which is a little more than 8, maybe 8.2, and about 5.5-ish. Okay, so the middle 50% of the data is there. This line in the middle is the median. So you just calculate the median, and that's what that line is. This down here, this dot here is an outlier. I can tell you how they calculated that, but it's really just a formula, and it'll say, anything outside of this range of values is an outlier. And I think we've done enough formulas for this week, so I'm not going to tell you that unless you want to hear it, and so let me know if you want to hear it. So this value down here is an outlier. So down here at about 1 is an outlier, and I think that's actually what the data point was. These values here, which are called the whiskers, are, other than outliers, they're the lowest and highest values in the data. So this is the smallest value because there's no outliers, that's 10.49. The highest value is 3.82. Or, I'm sorry, this is the highest value, and then down here is the lowest value other than the outliers. So this is what I'm going to ask you to talk about when you look at a box plot. So on your SPSS assignment this week, you should look at this description here for what to write about the box plot. This is the same box plot generated in SPSS. It looks the same way, but I wanted to point out this number down here, this 12, does not mean that this is an observation whose value is 12. In fact, you can see this value down here is 1. This 12 means that that's the case number. It means it's the 12th row in the data set. So if we looked at all the values in the data set, this one would be the 12th one. there is some value in, if you've got an unusual observation, you've got an outlier, in looking at that value. Maybe you can see what happened that caused it to be that extreme. Maybe you can look at, to see if, I don't know, if in this example, I don't know, I can't even come up with an example of what might have caused the wait time to be long. But anyway, so that's it for this lesson. And as always, let me know if you have any questions.